接下来，我们高兴继续邀请到 Paul Karazuba, Senior Product Marketing Manager for QuickLogic, 为我们发表 QuickLogic solves bridging issues with CSSPs. 掌声欢迎。
Good afternoon. Thank you for attending. My name is Paul Karazuba. I am the Senior Product Marketing Manager for QuickLogic, and today I'm going to talk about our new ArcticLink 3 VX products. I was here in August talking about our ArcticLink 2 for those who were, and I promised that I would come back and talk about the next generation, so that's what I'm here for. What I'm going to talk about first is some of the design issues that engineers faced when they're designing tablets or smartphones and what the costs and alternatives are for solving those problems. And then I'll talk about how the ArcticLink 3 solution addresses those issues and how it's optimum for system designers. So first, let's pretend we're all engineers, and let's pretend that someone like me comes to you and says, I have a great idea for a tablet. I want to use this processor. I want to use this display. It's going to be the best tablet computer in the world. But when the engineer looks really, really closely, he realizes my display interfaces don't match. And this is a very common problem that we have in smartphones. The reason for that is there's a variety of display interfaces that are available. When a processor maker like NVIDIA or Qualcomm is designing their processor, often they'll choose a single interface for the display, which can be MIPI, RGB, or LVDS. The same thing is true for the display makers, where when they're designing their displays, they'll choose an interface for that display. And as it says here, it gives alternatives during product design. The problem is, though, as I said in the previous slide, that the processor and the display very rarely or sometimes do not have the same interface. So what does someone do, a system designer, to solve this problem? Well, the first thing they can do is they can change their display or their processor to one that'll have the same interface so they can talk to each other. The problem with that is you have product changes. If your display changes, maybe your resolution changes, maybe your display size changes, and that changes the specifications of your product, which can make it maybe not sellable. And when you change components, you obviously extend your development time and potentially your costs. The alternative for changing, and this is something that's very common, is to use what's called a display bridge device. And those display bridges will simply change the MIPI interface, for instance, to LVDS. It's a single discrete chip, but the problem is that it adds a significant amount of cost into the system. They average about $1, and they can be as big as 14 by 14 millimeters, which is a lot of PCB space, especially in a smartphone, for instance. And as it says here, it performs a single function. So that's problem number one. I'm going to talk about two more problems. So, same mobile design. Marketing comes to engineering and says, I need 12 hours of battery life. Battery life, we know, is very important for smartphones, especially important for tablets. Smartphones and phones used to be rated in battery life in talk time, how long you could talk on your phone. Now battery life is how long you can surf the internet for, how long can you watch videos for, what is the standby time. So what are your options when a system designer has to increase the battery life of the system? Well, the first option is to add a higher capacity battery. But higher capacity batteries are bigger. Higher capacity batteries are also heavier, and higher capacity batteries also cost a lot more money. And within the constraints of a smartphone or a tablet, often there's not the room for a larger battery. The tablet or the smartphone cannot be heavier, and you certainly cannot increase cost by 2x for a single component. So what is the other option for extending the battery life during the design of a tablet or a smartphone? Is you reduce the power consumption of existing components within your system. And if you look at an average smartphone or a tablet, the display is going to consume about 50% of the total system power. And this is all on average. It changes a little bit depending on the system, but on average, displays consume about 50% of the power. The baseband application processor, the CPU, is going to consume about 30% of system power, and the other 20% is generally going to be consumed by the different antennas, Bluetooth, the OS, etc. So when you look at this, you realize the display is your biggest power consumer, and that's where you can probably get the most amount of savings. Now, power consumption on a display is most linked with brightness. The brighter your display is, the more power it's going to consume. And also, as we know, if you've taken your smartphone outside and you adjust the brightness up, your smartphone becomes more viewable. However, as I said, as you increase the brightness of your display, you're also consuming more power. So this is an example of what it might look like. This is probably very familiar to everybody. In a normal ambient light viewing environment, a conference room, the inside of your house with the lights on, this is what your tablet might look like under a normal brightness, maybe 60% brightness. Now, if you were to increase the brightness up to 100%, you get a great viewing experience on your tablet. However, as we show here, you're consuming a lot of power as compared to what you were before. Now, when you go outside, it's a completely different story. If you set your smartphone at 60% brightness and you go outside on a sunny day like today, or maybe tomorrow, your normal brightness, you're not going to see anything on your display. If you gain up the brightness all the way to maximum, you'll still be able to see some content on your display, but you're not going to be able to see everything. So this leads to the question, how does a system designer balance the need for power savings with delivering a high-quality viewing experience? And I promise you I'll answer that question in just a few slides. The third design issue that we'll talk about before we talk about the ArcticLink 3 is designing a smartphone with a Pico projector. I know Pico projectors have been talked about for 2 or 3 years as the next thing for smartphones or for tablets. What we're seeing at QuickLogic is what we call the inflection point. The Pico projectors are going to start becoming more and more common on smartphones and tablets very soon. So let's say we're a system designer, and again, a marketing person comes to us and says, I want to design a smartphone with a Pico projector. But when the engineers examine it, they realize that the CPU only has a single output. Let's call it MIPI. The Pico projector requires an input, and the onboard display requires an input. So how do you take a single video signal, duplicate it to 2, and then change or bridge it from one interface to the other? Well, the first option is to change your processor to a dual output processor. This is going to be more expensive. This is probably going to lead to a longer design time. The other option, as we talked about before, is to use a display bridge device. But of course, that adds cost into your system for a single function device and adds space into your system that you probably don't have. So this is where the ArcticLink 3 comes in. The ArcticLink 3 VX is a series of chips that are designed to bridge the mismatched display interfaces. So take an interface of one type and convert it to another type. It allows for the easy embed of a Pico projector into a standard system, and I'll explain how we do that in a few slides. It significantly improves display viewability, and I'm going to explain the theory behind VEE. Might be familiar to those who were at the August conference. And this chip allows you to extend your system battery life up to 50%, and I'm going to explain how we do that as well. Some quick facts about our ArcticLink 3 product. There are 13 distinct silicon variants within the family. So there's 13 different parts. In display bridging, pass-through and dual output variants, and I'll explain that. It's ideal for smartphones and tablets, and it complements our existing ArcticLink 2 VX product that I talked about during the last technical forum. So exactly what does it do? For display interfaces, we bridge between the RGB, the MIPI, and the LVDS interfaces with support up to full HD, actually greater than full HD, 1920 by 1200. So this product allows us to bridge the interface from a processor to the interface that the display wants to see at greater than full HD resolution at 60 frames a second. So this is an extremely fast chip. For Pico projectors, there are variants of this chip that accept a single MIPI interface from the processor, and then on our chip, we output a MIPI interface to the embedded display and an RGB interface to the onboard Pico projector, which allows the Pico projector to be easily inserted into the standard system. For display viewability, our VEE technology, which I'll speak about in one slide here, it greatly enhances the viewing experience in all lighting conditions. And our DPO full HD technology extends single charge system battery life by up to 50%. I'm going to show you some figures of exactly how we come up with that number. So what is VHD and how do we get a much better viewing experience? Well, V is it's a display viewability optimization technology. The technical description is it optimizes the display content's contrast ratio, dynamic range, and color characteristics on a pixel-by-pixel, frame-by-frame basis to provide optimum viewability based on the human visual system. That's a very long sentence. And if English is not your first language, you probably didn't understand it, but it's okay. What V does, and I'll show you the example right here for those of you who can see this screen. Before V, this is what your image may look like on this screen. It's a good-looking image. But after V, what you'll notice is that we've greatly enhanced what you can see in the tree areas here. We've also added much more detail into the clouds that you couldn't see before. What V does is, as the display content is sent from the processor to the display, we optimize it for what your eyes want to see based on ambient lighting and also based on what the content actually is. This is what it actually results in. We showed what this chart looked like before. With normal ambient light, without V, that's what your display might look like. And with V, that's what you're actually going to see on your display. And in bright sunlight, without V, that's what you'll see. And with V, that's what you'll see. The key thing to note here is we're not increasing the display brightness. We're actually lowering the display brightness, and I'll explain how we do that in one slide after this one. One other concept, I talked about Pico projectors. As we see here, without changing the projector intensity or the lumens coming out of the projector, we're able to greatly increase the viewability. This is what it looks like. This is a Pico projected image taken with V and without V. These two pictures, it's the same Pico projector, the same brightness of the bulb, the same distance. The only thing we've done is we've added V technology into the second picture. As you can see, it's much more viewable, and this is what it's going to make Pico projectors in your smartphones actually make sense, is the word. You'll be able to see what's coming out of your phone in a normal lighting environment. You don't have to turn down all the lights in the room to see the Pico projected content. We call that effective lumens. Lumens, of course, is a measure of bulb intensity. Effective lumens is a measure of how much your eye can actually see. So I mentioned power savings. That comes about through our DPO, or Display Power Optimizer technology. I mentioned that the display brightness has not changed, but the content is obviously a whole lot more viewable. I should say that after my talk here is done, we have two examples of products with this technology out front. I can actually show you what it looks like. But for right now, what I'll say here is that our DPO technology works with V. Because V can make an image look so much better than what it was before, our DPO technology can actually reduce the brightness of the display and save you power. This is a chart that I showed in August, and I think it's important to show again. This is 3 different examples of products that we have inserted our V technology into and our DPO technology into. 2 tablets and a smartphone. How we measure DPO power savings. Well, the first thing is we measure the original brightness level that the system was set at. In this case, the original system was set at 90% brightness. The system consumed 2.42 watts of power at that brightness. Now, because of our V and DPO technology, we were able to reduce the brightness from 90% to 30% without negatively affecting the viewing experience, meaning even though the brightness level was reduced by 60%, the viewing experience was still better. Now what that translates to is the system power goes from 2.42 watts to 1.42 watts. And that's directly due to the reduction of the brightness of the display. That's obviously very significant. That's a savings of 1 watt. And that, of course, also includes the power consumption of our chip. What that results in is a 41% extension of battery life. And this is in an existing system. One other technology that we've added into our ArcticLink 3 is a technology that we're calling Intelligent Brightness Control, or IBC. This is a content-based power savings. When you are streaming YouTube videos or watching content that is of lower contrast or lower dynamic range, we can further lower the brightness of the display without negatively affecting the viewing experience for another 10% in power savings. So I've talked about this technology. The first question obviously is it really important? Does it really matter? Is there really a market for it? No matter how nice it looks, will people actually buy it? For display interfaces, IHS iSupply, which is a very large market research firm based in the United States, has said that more than 60 million smartphones are going to ship this year with mismatched interfaces, which means 60 million smartphones that are going to be produced this year are going to have to use a bridge chip. And that's just smartphones. That's not even including tablets. I'm sure tablets is a lot as well. The ArcticLink 3 allows the OEMs to independently choose the processor in the display, not the processor in the display that talk to each other out of the box. For Pico projectors, global industry analysts is forecasting 97.5 million units by 2017. $10 billion. It's a very big market. We allow for the easy and better Pico projectors without complicated design and routing. For display viewability, anyone who has an iPad, and I'm sure a lot of us here have iPads, you go outside, as the quote here, it basically makes it nearly unreadable. Our VEE technology allows OEMs to have hardware differentiated products that are viewable in all lighting conditions, and we support the high resolution displays that consumers are more and more demanding. And finally, for battery life, I'm not satisfied with the battery life of my smartphone. Is anyone in this room actually happy with how long the battery lasts in your smartphone? Didn't think so. DPO will get you up to 50% longer battery life in an existing system by inserting our chip into it. And of course, as we say here, it eliminates the alternative of a heavier, bulkier, more costly battery. During the last conference, I talked about the ArcticLink 2. I want to talk about how we've changed in the next generation. The ArcticLink 2 supported two interfaces, RGB to RGB and MDDI, the Qualcomm standard, to RGB. The ArcticLink 3 supports 13 different configurations, so obviously we've increased the number of variants by a lot. The maximum resolution that we support has gone up 54%. We used to support WXGA, we now support WUXGA. The power consumption of the chip, if you look at the maximum resolution, the ArcticLink 2 consumed 123 milliwatts of power. The ArcticLink 3 supports 52 milliwatts of power. That's a power reduction of 58% at the maximum resolution of the chip. Now, if you look at the same resolution, 1366 by 768, we've reduced the power consumption by almost 80% from generation to generation. I've talked about how DPO reduces the power of your system. Absolutely it does, but OEMs care about the power consumption of the chip. No matter how much power we save, it still is important how much power our chip is consuming. And over the generation, you can see that we have significantly reduced that power. And finally, package size. Obviously, you can't get bigger in a smartphone. That doesn't happen. We've reduced the size of our chip by 44%, from 6x6 to 4.5 by 4.5. So even though we're supporting much faster speeds and much higher resolutions, we've reduced our power considerably, and we reduced the size of our chip considerably as well. We call this an eye test chart in the United States, meaning that it tests your eyes to actually be able to see what's on it because there's so much data. So I'll go very quickly. These are the different variants of the ArcticLink 3 that are designed for smartphones. This is the chip input or the processor output, and this is the output that our chip provides to the display, the maximum resolution that it supports, and then the part number. A couple of things that we'd want you to note here. I talked about Pico projectors. These two products are ideal for Pico projectors because it takes a single output signal from the display and then converts it to two different outputs, one for the Pico projector and one for the onboard display. And then another thing to point out is I talked about there being 60 or 70 million smartphones that have bridges, that need bridges. Well, What about the other 400 million smartphones that don't need bridges? Obviously, we can't forget that market. So we have our MIPI to MIPI solutions, which offer the value of VEE and DPO without the added cost of bridging. The same slide except for tablet products. What changes with tablets is the LVDS interface. The LVDS interface is very popular for tablet displays. So for tablet markets, we have MIPI to LVDS versions, RGB to LVDS versions, etc. I won't go through each one of these variants. It's probably a bit much for people. It's been a long day, I'm sure, already. And then, of course, Pico projectors. System block diagram. This is exactly how our chip actually fits into a system. We receive the RGB or the MIPI display content directly from the CPU. We communicate through the CPU through I²C, and this is just simply for command and control. All of the VEE processing is done on our chip. We don't require any host system resources other than simply power to operate. We then output the RGB, the MIPI, or the LVDS signal to the display, and we can do the PWM control of the display directly if that's how the OEM would choose, or we can control the PWM through the I²C interface. We receive ambient light data for our VEE algorithm to process through the onboard system as well. And this is what a block diagram might look like for a system with a Pico projector, where the single display interface in, and then the RGB to the Pico projector, and then MIPI directly to the onboard display. So in summary, this is how the OEM and the user would benefit from the ArcticLink 3. First, for bridging, the OEM benefits from a high-speed display interface bridging device in a multifunction chip. I mentioned earlier that existing display bridges are large in size and they perform one function, and that's to bridge the chip. We've put bridging in with display enhancement and with power savings in a single chip that's much smaller than what's out there on the market today. And the user benefits from a no-compromise design, meaning the best display can be chosen and the best processor can be chosen, not the display and the processor that best talk to each other. For Pico projectors, our system gives the engineers a less complicated design, and you can bring the product to market quicker. And as I talked about earlier, the user experiences greater effective lumens from their Pico projector. For VEE, better user experience and product reviews. Obviously, that's very important that customers actually like their products to OEMs. And the user benefits from being able to use your smartphone or your tablet wherever you are. You don't have to go and hide and cover your smartphone so you can actually see what's on the display. We've all done it. And then DPO, extended battery lifetime is a superior selling point. The iPad's battery life is the third feature that Apple advertises on their website. Obviously, it's very, very important. And the user benefits from less charging time and more use time. And that is key for everybody. The carriers want people using their phones. The OEMs want people using their phones. They don't want us sitting there charging it, because then we can't pay for data, we can't pay for content, etc. So finally, the ArcticLink 3 VX is going to be sampling in Q1 of 2012 with mass production in Q3 of 2012. Each one of the 13 products that we showed earlier has the VEE and the DPO technologies inside of it. And finally, this is our company contact information. Should you have any questions that we don't answer in the Q&A session, or should you want to get in touch with us, this is how you do so. So at this point, we'll have a question and answer session, and I have one of my local colleagues, Albert, who is a Chinese speaker. So if you feel more comfortable asking your questions in Chinese, please do so, and Albert can answer those questions in Chinese. So Albert, why don't you come up and join me? Come on. we can trade microphones. So what questions do people have?
在座呢有没有宝贵的问题呢？都可以现在提出进行交流。好，稍等一下我们的麦克风。
Yeah, I can speak English direct to you.
Thank
I
you.
have a question. Maybe I'm wrong. Okay. So I'm wondering, you're talking on the big size, resolution for a screen, and how about a small size? And also, you mentioned about a projector. So, is anything other than projector?
The VEE algorithm, the ArcticLink 3 supports up to 1900 by 1200, but it supports small resolutions as well. We can go as low as a 320 by 240 pixel display. As far as sizes of the display, VEE really doesn't care. We have implemented VEE on screens as small as 4 inches and as screens as large as 11 inches. But again, we really don't care how big the screen is. As far as other technologies, VEE is designed for smartphones and tablets. This product also targets Pico projectors. However, we have implemented VEE in other applications such as digital signage, so advertisements that you may see when you're in a train station on electric billboards, things such as that, aviation, etc.
Thank you very much. But regarding the second point, and how about like PMP and portable, and that will be very cost sensitive. So I don't know your solution will be overhead for those type of application.
You know, we have implemented this technology in portable media players, yes. The cost sensitivity of, it's amazing that even that smartphones sell for more than a portable media player. The bill of materials is generally larger, and so there is, I think there is a lot of cost sensitivity in that market as well. We haven't talked about specific pricing in this presentation. I would just say that obviously you would think that as we've shrunk the size of the die, of course the pricing comes down as well. So this, we understand the sensitivity of the markets that we serve, and we certainly think we're priced at the right level.
好的，感谢您的提问。还有没有在场朋友有继续有相关问题，欢迎提出来进行交流。好的 ，Thank you very much, Mr. Karazuba。再次感谢您的演讲。接着下来呢，我们有20分钟的中场休息时间。